All right, this is Chapter 10, Lesson 1, Volume of a Rectangular Prism. So, when I'm dealing with volume, volume is what's inside, it's what fills up like a cup, for example. So all the water, that's volume. Okay, so we've dealt with surface area, which is around the outside, which is actually the area of the physical object, of a three-dimensional object. We've dealt with area of a flat surface, we've dealt with perimeter. So this is volume, what's inside. So a rectangular prism, so obviously it has to be a rectangle, okay? And a prism just is a three-dimensional object. So the volume V of a rectangular prism is the product of the length, the width, and the height. It's also the area of the base, so the big B, the big base, okay, times the height. So a blank, blank, blank has length, width, and height. A blank is a three-dimensional figure with two parallel bases that are congruent polygons. In a blank blank, the bases are congruent rectangles. So in those blanks, you're going to write three-dimensional figure. Yes, you can abbreviate using a 3. That's fine. You don't have to spell out 3. Has length, width, and height. A prism not to be confused with prison. Prism is a three-dimensional figure with two parallel bases that are congruent polygons. In a rectangular prism, the bases are congruent rectangles. Means the bases are the same. They're both congruent rectangles, okay? Blank is the amount of space inside a three-dimensional figure. It is measured in blank, blank, which can be written using abbreviations and an exponent of 3, such as units cubed or inches cubed. So in those blanks, you're going to write volume. So volume is the amount of space inside a three-dimensional figure. It is measured in cubic units. Cubic units. And they're written with an exponent of 3. Or they're, say, cubic units or cubic inches, anything like that. Decomposing or breaking down the prism tells you the number of cubes of a given size it will take to fill the prism. The volume of a rectangular prism is related to its dimensions, length, width, and height. Another method to decompose a rectangular prism is to find the area of the base. Notice it's a big B, not the little b. So the area of the base, which is this first layer of cubes, and multiply it by its height, which would give you every other layer as well. So the area of the base, or the number of cubes needed to cover the base, the bottom layer. Okay, and then the number of rows is the height. Okay. So finding the volume of a rectangular prism. Again, volume is length times width times height. So you just multiply those three numbers together. They only give you 3 numbers and it's a rectangular prism, you multiply them together. 5 times 4 times 3 gives you 60. Okay? And it's 60 centimeters cubed. So the volume is 60 cubic centimeters or 60 centimeters cubed. Make sure you include your units. You must include your units. Okay? The other part of this is finding a missing dimension. So say you're given the volume, but you need to know how high something is, or how long, or how wide it is, okay? You can use finding the missing unit, or finding the missing dimension in order to solve this, okay? To find missing dimensions of a rectangular prism, replace the variables with the known measurements. Then solve for the unknown measurement. So, finding the missing dimensions of the prism, V equals LWH. They told me that the volume was 84, my length was 6, my width was 4, and my height we don't know. That's what we have to find. So 6 times 4 gives me 24. 84 divided by 24 gives me 3.5. So my height has to be 3.5 meters. Okay. You can always double check. 6 times 4 times 3.5 does give you 84. All right, there are a couple of try problems out below. I want you to go ahead, pause the video, try them out, and when you're done, we'll go over the answers together. All right, now that you've had a chance to try out the try problems, let's go over the answers together. So for letter A, I'm given 2 lunch boxes and asked to figure out which one holds more. Okay, so which one has the bigger volume? Looking at them, you can't actually tell which one has the bigger volume. So I have to figure out what the volume of lunchbox A is and what lunchbox B is. So lunchbox A is 3.75 times 7.5 times 10. Okay? So I have 3.75 times 7.5 times 10. So lunchbox A is 281.25 cubic inches. Okay? Lunchbox B, 9.5, 3.75 times 8. So lunchbox B is 285 cubic inches. So lunchbox B is bigger than lunchbox A, holds more. So if you want more food, take lunchbox B to school. Okay? So for letter B, I'm asked to find the missing width. So I'm giving volume is 94.5. Length is 7, height is 3, and I want to find my width. Okay. So my formula, V equals LWH. So my volume I was given as 94.5. My L is 7. W was not given, and my height is 3. It doesn't matter what order you multiply these numbers in. Okay, it actually doesn't matter. Commutative property of multiplication says I can multiply in whatever order that I want to. Okay, and I'll get the same answer. So 7 times 3 is 21. So I have 94.5 equals 21W. I divide both sides by 21. The opposite of multiplication is division. And whatever I do to one side, I have to do to the other, which gives me 4.5 equals W. So W is 4.5 kilometers, because that was the units they gave me. I can always double check. 4.5 times 7 times 3 gives me 94.5, which is what I had started with for my volume in the first place. All right, letter C says find the volume of a container that measures 4 inches long, 5 inches high, and 8.5 inches wide. So volume is length, width, height. So my 4 inches long, 5 inches high, so 8.5 times 5. Again, doesn't matter which order you put them in. So I multiply 4 times 8.5, or 8.5, times 5. So volume is 170, and they said inches, so it's inches cubed or cubic inches. And that is the end of Chapter 10, Lesson 1.